Hello everybody and welcome back to Math 7 again. So yesterday we talked about congruent and similar figures and what those two things mean. And today we are transitioning into being able to find missing parts of similar figures. So using information from other triangles or quadrilaterals to figure out missing parts of other ones that we have that we might not know but need to. So, just a quick reminder that similar figures have congruent angle measurements. That means that they are the same angles, and that similar figures are not the same size, but they have proportional side lengths. And this is the big key into how we figure out the missing parts of other figures that we're given. So, if we take a look at these two triangles here, we have ABC and DEF, two triangles. So what we are doing is we're taking a look at what did they do to side length AB here to get from this length to this length, DE. So how do we get from 10 to 20? Well, that's pretty simple. We multiplied by 2. Now, what did they do to get from BC here to the length of EF? So how do we get from 6 to 12? Well, that is also timesing by 2. And then from AC to DF, well, getting from 7 to 14, again, multiplying by 2. So hopefully this is looking a little familiar here. We've done this before, but with tables instead of side lengths. So since the same thing was done to every side, we multiplied each side by 2, we say that triangle ABC is proportional to DEF. So they are similar. So they're proportional because we multiplied or divided by the same amount to every side to get to the new side length. So we may not so in the last assignment we were told that the figures we were dealing with were similar. We might not always be told that, so we need to be able to check to see if they're similar. So the steps to do that, checking to see if ABC is similar to MNO. So the first thing we need to do is, if they are the same shape, we have to check to see if their sides form a proportion. So remember, proportion means equal ratios. So they're going to set up a proportion for their two similar sides. So AB here, let me get another color going on so we can see. So they're setting up a proportion. So AB, a ratio with NM, and they did that here, 7.5 AB divided by 3, which is NM. And then they did BC, so this 12.5 here, divided by 5. So they got that here. And just to verify that they have a proportion, we're going to calculate out the side of that. So I've got my calculator here. So 7.5 divided by 3 is going to give me 2.5. Is that equal to the other side? Well, 12.5 divided by 5 is 2.5. So yes, they are a proportion. They are both equal to the same thing. So now we're going to test again with two different sets of sides. So once again, they use their, they use their 7.5 divided by 3 here. So they did AB once again and NM to form a proportion. And then they used the other side, the one that we haven't used yet. So 10 divided by 4 here, setting up that ratio. So 10 divided by 4 is equal to 2.5. And 7.5 divided by 3 is equal to 2.5. So once again, they form a proportion. So we know that these two things are in fact similar to each other because we got the same proportion, the same ratio when we set up each set of sides. So now that we've practiced with proportions, so we have to do corresponding sides here. So let's just get after it. If we are told that these two triangles are similar, we can find x by setting up a proportion. So the 3.5 centimeter side is similar to the 5 centimeter side. And so the 3.5 right here, they're saying is similar to here. So they set up their first ratio here. And then they're also saying that 8.4 right here is similar to this missing x. And they set up their other proportion. So just like setting up any proportion, they have the same things on top. So they're telling us here that the little triangle's measurements are on top. So this guy here is on top of our fraction, and then this guy here is on the bottom of our fraction. So once you have your ratios, I'm just going to set up here 3.5 equals 8.4 over x. Well, this is where we're going to do our butterfly method once again. Boom. So 3.5 times x is equal to 8.4 times 5. So let me just figure that out real quick. 8.4 times 5. I know it's written there, but I'm just double checking. So we're just going through the exact process it tells us that they're doing up here. Divide by 3.5, divide by 3.5, and we get x is equal to 12. So that means that this missing side here is 12 centimeters. So we just figured that out by using proportions, equal ratios. So we're going to practice here with a couple, and then you'll be off on your independent practice. So part A, so we've got two triangles that are similar. So we're going to go little to big. So we're going little on top, 12, and its corresponding side is 15. Set that equal to little on top, so 6.4, and its corresponding side, well, that's the one we don't know. That's what we're trying to find. So do our butterfly method. 12x is equal to 15 times 6.4 is 96. Divide by 12, divide by 12. So that means that that missing side is equal to 8. So this isn't x anymore. We figured it out. We know it. This is 8 centimeters long. And this doesn't only work with triangles. We can do this with all kinds of shape, quadrilaterals too. So once again, we're going to set up. We've got HE is similar siding to DA. So we're going 4 over 17.2. Set that equal to, and HG here is similar to DC. So we're going 8 over x. And that's kind of the hardest part here, is figuring out what is similar to what and setting up your proportion. But once you have that set up, 4 times x is going to be equal to 17.2 times 8. And we get 137.6. Divide by 4, divide by 4, and x is equal to 34.4. So it's no longer unknown. We have figured out that this is 34.4 in length. And And that's where these proportions continue to be very useful to us. We can find missing things of similar figures by using that setup of equal ratios. So today, your independent practice is going to start below here. So go ahead and complete this assignment, and then just be sure to check if there's an IXL for today. I haven't found one that corresponds to what we're doing, but if I do, I will definitely throw it on there, so just be sure you're checking. So go ahead and finish up this independent practice. There's this page right here, and then another page, so be sure you're completing both of those PDFs there when you turn it in. And after that, you are done for the day, so be sure to check for that IXL as well. And as always, if you have any issues or you get stuck, just send me an email or a message on Canvas, and I will be sure to respond as quick as I can and help you out. All right, thanks, and I will talk to you again here soon.